Okay. All right, so we're recording fifth period for the first time, and they're really excited about it. So fifth period, say hi. 1, 2, 3. Hi. Okay, fifth period was excited about that. So, all right, Seth calls shenanigans. All right, so on notes 4-6, it says we're going to be using a table to write an equation. So these notes right here, like they're helpful if you're totally lost, but I'm not going to go through them because they're long and wordy. So I'm just going to show you how to do it, and then you can come back and refer to the steps later if you need them, like while you're doing your homework, okay? So I'm starting at example 1. Everybody find example 1 on your paper. All right, so the way that you take ordered pairs and put them in an equation is by using a table that has an extra column. All right, so on your paper, make a table that looks like this. This column right here is going to represent your x values, and the one way over here represents your y values. And then this one in the middle is your process column. Okay, so we're going to take all of our x values from the table and put them here. So our x values are 1, 2, 3, and 4. We just write it like this: 1, 2, 3, and 4. And then our y values, the -2, -1, 0, and 1, we put over on this side. Okay, so that part you should not have too much of a hard time with. Now this next part is brand new information, okay? When you make a process table, the first thing that you want to look for is the thing called the change in y over the change in x. So write that on your paper. Yeah, this little triangle-y deal is actually a Greek letter called a delta. And in math, when you see a delta, it represents the word change. So what we're going to try to find is the change in y over the change in x. So to find the change in y, here are our y values right here, right? So what is the change from -2 to -1? How does our graph change? Goes up by 1, right? So we put a 1 there. And then from -1 to 0, it goes up by 1. And then from 0 to 1, it goes up by 1. It goes up by 1, plus 1. Goes up, right? Yeah. Okay, so our y's did what each time? They go up by 1. So our change in y is 1. If you want to. Okay, now I'm going to come over here and I'm going to do the x's. So from 1 to 2, how does it change? Goes up 1. From 2 to 3, goes up 1. And from 3 to 4, goes up 1. Okay, so what is our x changing by each time? 1. So I put 1 over 1. All right, now notice this is a fraction, right? Okay, can I reduce that fraction? Yeah. 1 over 1 reduces to 1. Okay, so my rate of change, or the amount that I am changing by each time, is 1. All right, so I take the rate of change. In this case, the rate of change is 1, and I put it here. Then I look for my x value. In this case, my x value is 1. So I put times 1. And then I kind of have a little conversation with myself. I'm like, okay, what is 1 times 1? 1. But I need for my answer to be -2. So how do I get from 1 to -2? -3. Okay? So I did 1 times 1 was 1. But then to make the answer be -2, I had to subtract 3. Okay? Now, because our rate of change was the same each time, that pattern will work for each row. Okay? So, the rate of change was 1, so I put it here. But on the next row, my x value has changed to a 2. So I do 1 times 2, which is 2, minus 3 is negative 1. Okay? So I put my rate of change again, which was 1. Then I multiply it times my x value, which is 3. So 1 times 3 is 3. Minus 3 is 0. Good. Okay, and then I put my rate of change again. 1 times my x value, which is 4. So 1 times 4 is 4. Minus 3 is 1. Okay, so now what we did each time was we took 1 times whatever our x value was and subtracted 3, right? So for our equation, we're going to write our y value is 1 times the x value minus 3. Not that bad. No, it's going to change depending on what your rate of change is. We'll do another one. Yes, ma'am.
So for homework,
Uh-huh.
all of that, is that like going to be one answer, or would it just be the equation and the answer?
Probably just the equation. Yeah. All right, let's look at example 2. Okay, on example 2, we're going to make another process column table. So we have x process y. Okay, this time our x values are here. Our x values are 0, 6, and 9. And then our y values are 7, 3, and 1. Okay, remember the thing that you're always going to look for first is your change in y over change in x. Okay, so we're going to look at the y values first. So from 7 to 3, how is our y value changing?
4.
Good, minus 4. And then from 3 to 1, how is our y value changing? Minus 2. Now, just because you get different numbers here doesn't mean that you did something wrong, okay? But you do have to go ahead and check your x values as well. So on my x values, how does it change between 0 and 6? Plus 6. And then how does it change from 6 to 9? Plus 3, right? So remember, we always put our delta y over our delta x. So the first time we looked, our delta y was negative 4, and our delta x was positive 6. So if I put negative 4 over 6, I still have a fraction. What do we notice about that fraction? What are some things you see about that fraction? Numerator is negative. That's true. Okay, what else? Oh, good. It can be reduced. That's what I was looking for. Okay, so your calculator can reduce fractions for y'all. Do y'all remember how to do that? Okay, let me show you. If you're on your home screen and you want to reduce your fraction, you're going to do negative 4 over 6, and then push math, enter, enter, and it will reduce for you. So negative 4 over 6 reduces to negative 2/3. Okay, so I just reduced negative 4 over 6 to negative 2 over 3, right? Okay, so on this next delta y over delta x, my rate of change for y is negative 2, and my rate of change for x is positive 3, which if I look here, that's the same thing I got the last time. All I did was reduce. All right, so my rate of change was negative 2 over 3. So that's what I'm going to put here in my process column as my first number is negative 2 over 3. That's the rate of change. Okay, the next thing I do after I put my rate of change is multiply it by the x value. So here the x value is 0. So I do negative 2/3 times 0. What is negative 2/3 times 0? 0, but I need for the answer to be 7, so plus 7. Yep. Okay, now I'm going to do it again with a 6. So I'll do negative 2/3 times 6. So put that in your calculator. Find out what negative 2/3 times 6 is. It's negative 4. Okay, so if I need to go from negative 4 to positive 3, what do I have to do? Yep, got to add 7 again. Okay, and then on this one, I'm going to do negative 2/3 times 9. So what is negative 2/3 times 9? Negative 6 plus 7 would be 1. So for this one, what is the equation? Negative 2 over 3 x plus 7. What's the only thing we left off? Y equals. That's very important. You got to include that. So y equals negative 2/3 x plus 7. Good. All right, flip over onto the back. Let's look at example 3. All right, on example 3, we don't have a table. We just have a list of ordered pairs. But we're going to take that list of ordered pairs and put it into a table. Okay, so make your process columns. So I have x and y and my process. Okay, my first ordered pair is 1, 3, so I write it like this. The next ordered pair is 2, 6, and 3, 9, and 4, 12. Okay, then what are we looking for first? Which is called change in y over change in x. Okay, so what is my y value changing by each time? 3, right? And what is my x value changing by each time? 1. So my y changed by 3, and my x changed by 1. So 3 over 1, I can reduce. What would that reduce to? 3. So I'm going to leave that right there. Okay. Then that's the first thing I'm going to write here in my column as my rate of change. So I do 3 times my x value of 1. So 3 times 1 is 3, which is the number that I already have. Yeah, you just leave it alone. You don't have to plus or minus anything on this one. So for the next one, I would do 3 times 2 and get 6. 3 times 3 is 9. 3 times 4 is 12. Okay, so what would our equation be? Yep, y equals 3x. Good. Okay, so what is the coefficient of the equation?
3.
Good, 3. Okay, this is the coefficient. What is the constant? There's not one, right? So what number represents nothing? 0. So the constant would be 0. What is the independent variable? Okay, if you forget, where are you supposed to look? On the little chart over there. Okay, which one is the independent variable? X. It's next to the 6 up there, huh? Okay, and then what's the dependent variable? Y. Y would be the dependent variable. Good. All right, we got one more, and then we're done. All right, so on example 4, it says use the points from the graph below to find the function that describes them. Now here, it doesn't come out and give us the points, so you've got to look for them on the graph. You're still going to make a table. So I have x, process, y. Okay, and what I'm going to do, and it doesn't really matter what order you go in. You can start on the left or you can start on the right, whatever you want to do. But I normally start over here, but like I said, it doesn't really matter. So when I look at this ordered pair, I can see that it's at -6, +8. So that's the first ordered pair that I'm going to record. Okay, then the next one is -3, 4. Okay, then I have one on 0, 0. And then 3, -4. And then the last one is 6, -8. All right, so what are we going to look for first on this one? The differences in the numbers, which is called what? Change in y over change in x. Okay, so each time my y values are doing what? Okay, I'm subtracting 4 each time there. Okay, and what's happening with my x values? Adding 3 each time. So my change in y is -4, and my change in x is +3. Now, this one, I can't reduce -4 over 3. A decimal doesn't really make sense when you're doing stuff like this, so I prefer the fraction. But don't change it to a mixed number. Leave it as an improper fraction. That's okay. All right? So I'm going to take this -4 over 3, and I'm going to write it here in my column, -4 over 3. And then I'm going to multiply it by my x value, which is -6. So in your calculator, do that. What is -4/3 times -6? It is 8? Okay. It should be +8, right? Okay, it is +8. Okay, so we're done there. We don't need a constant. Okay? So then I'm going to do -4/3 times -3. So what I get when I do -4/3 times -3? Should get 4. And I'm going to do -4/3 times 0. That's 0. Right? And -4/3 times 3 is -4. And then -4/3 times 6 is -8. Okay? Now, it doesn't ask for it, but what would the function rule be for this one, or equation be? Yep, y equals -4/3 x, right? Okay, then it says, would the ordered pair 4, -6 fit the function and justify your answer? So to find the answer to that, what we're going to do is take our function and put it in our calculator. So we're going to go to y equals, and we're going to put in y equals -4 over 3 x. Okay? And then I'm going to go to the table and see if this ordered pair is in the table. So how do I get to the table? Second graph. Okay, so I'm looking for 4, 6. Do I find 4, 6? No, I don't find 4, 6. So what I'm going to do is say no. And what would be my justification or my reasoning? Yeah, it's not an ordered pair that fits the function. So I could say when x is 4, y is, what was it, -16/3? Something random? Yes. Okay, then on B, it says, would the ordered pair 32, -16 fit the function? So we got to find 32. Instead of scrolling all the way to 32, what can I do? Second window, and type in 32. Okay, so when x is 32, y is -128 over 3. So would the ordered pair 32, -16 fit? No. And it's about the same reason. So when x is 32, y is -128 over 3. Okay, and then on part C it says if x equals 100, what is y? So how can I find that in my calculator? Second window takes us to the table setup. And we want to start our table at 100. So I type in 100 right there. And then I go to the table. And when x is 100, y is negative 400 over 3. Good. Extra credit. Oh, yeah. Thank you for reminding me. Okay, we are done with the notes. There's the homework. It's only 7. Oh, you want me to go back? Okay. It's only 7 problems, I believe.
7.
Okay. 4, 14, 32a, 34, 8, 20. No, it's 8. My bad. No, 7. I can't count.